Dear students, welcome to our science episodes. Today we will continue discussing matter and its characteristics. Now let's discuss melting point as a property for matter. It's the temperature at which matter begins to change from solid state to liquid. What is meant by melting point of ice is 0 degrees centigrade. If the ice in the glass will melt at 0 degree centigrade, this means that it will change to liquid water. This means that the ice starts to change to water at 0 degrees Celsius, which is the melting point of ice. Does melting point differ from substance to another? We will see together in this activity. Now, in a water bath, we will put some crushed ice in a thermometer in a beaker. We will put this water bath on a flame and heat for some time. When the ice begins to melt, we will take the reading of the thermometer. And then we will repeat the procedure using solid wax. Instead of ice cubes, we will put solid wax with the same mass of ice. And then record the thermometer reading again when the wax begins to melt. Do you think that the melting point of wax will be the same as ice? Of course not. The melting point of ice is lower than that of wax. And the conclusion is melting points of substances differ from each other. Some have low melting points like butter, ice, and wax, while others have higher melting points like copper, aluminum, iron, and table salt. Let's discuss some life applications. Why are cooking pots made of aluminum or stainless steel, which do not rust? This is because they have high melting point, so they can bear the high heat while cooking. Why do manufacturers heat metals to be molten? Sometimes they heat metals until the metals melt. Why? So they can easily shape them to make alloys like gold copper alloy used in making jewels or nickel chrome alloy used in making heating coils. Now let's discuss together boiling point. It is the temperature at which matter begins to change now from the liquid state to the gas state. What is meant by boiling point of the water is 100 degrees Celsius? This means that at 100 degrees Celsius, the liquid water, will change to water vapor or steam. Does boiling point differ from substance to another? Let's see this example. This is the crude oil or the crude petroleum oil. When scientists want to separate the components of the crude petroleum oil so they can get the gas, the gasoline, the petrol, the kerosene, the diesel oil, the fuel, and the paraffin wax, they depend on the boiling point of each substance. So they heat the petroleum or the crude oil, and then we can extract the gas at only 20 degrees Celsius. The petrol or the gasoline at 150 degrees Celsius. This is the boiling point of petrol. So, because the boiling point of the substances are different, we can separate the components of petroleum. So this means that different substances or different matter have different boiling points, exactly like the melting point. Hardness. Solid substances differ in hardness. Some are soft at ordinary temperatures, such as rubber. Rubber is a solid, but it's elastic, soft. And some need heat to get softened, such as metals. Metals are not soft. Other solids cannot be softened if heated, such as coal and sulfur. Now, here is a question for you. Why it's easy to shape metals like iron, but not coal or sulfur? This is because metals like iron is softened when heated, but coal and sulfur do not. We said that hardness differ from substance to another. Let's discuss some life applications. Why are construction rods? These are construction rods used in building, and they are made of iron, not copper. Why iron and not copper? This is because iron is harder than copper. So I can depend on iron in building houses and big buildings rather than copper, which is softer than iron. Another property, which is electric conductivity. And also substances differ in their electric conductivity. We have good electric conductors. Metals, most of metals are good electric conductors, such as copper, aluminum, silver. Also acid and alkali solutions. Some salt solutions like table salt solution. Yes. Do you believe this? Yes. Some solutions are good electric conductors. They can pass electricity. While others are bad electric conductors, like wood, plastic, sugar, water, solution of hydrogen chloride in benzene, and gases. Can you tell me why are electric cables made of copper or aluminum with a plastic cover? This is simply because the copper is a good conductor of electricity. So the electric current will flow through the copper easily. And the cable is covered in plastic because plastic is an insulator. It's a bad conductor of electricity. So when you will touch the cable, you will not get electrically shocked. Why are screwdrivers made of iron steel while its handle is made of plastic, rubber, or wood? The same idea. Iron is a good conductor of electricity, so I can use it in fixing electrical appliances, while the handle is plastic, wood, or rubber because they are bad conductors of electricity or insulators. So it protects us from getting an electric shock. Thermal conductivity. The word thermal refers to heat. Again, substances differ in their thermal conductivity. Some are good conductors, like metals, and some are bad heat conductors, like wood and plastic. Look at this cooking pot. The heating pan or the pan is made of aluminum, while the handle is made of plastic. Because of course the aluminum is a good conductor of heat, so it will cook the food, while the plastic is a bad conductor of heat, so you can carry it safely without being burned. We are done with the physical properties of matter. And now let's discuss together chemical properties of matter. Metals differ in their chemical reactivity. So we have highly reactive metals like sodium and potassium. Sodium and potassium react instantly with oxygen as soon as they are exposed to moist air. Can you tell me why we keep sodium and potassium under kerosene? That is because they are highly reactive. When they will be exposed to the moist air, they will react instantly. So, to prevent the reaction, we keep them under kerosene. Less reactive metals. They are reactive, but less than sodium and potassium, like iron, copper, aluminum. They react with oxygen, but after days, forming a layer on the surface. What do you think if you will leave iron exposed to air? It will rust. Here is the layer on the surface. This is the rust. So iron will react with oxygen if left in air for days, forming a layer on the surface. Why do you think metallic bridges and light posts in streets are painted from time to time? To prevent them from rusting. And why cars are coated with grease? To protect them from rusting and erosion. Why are cooking aluminum pots rubbed with a rough material to clean them? You know, when your mom is scrubbing the aluminum pots with a rough material to clean them, that is to remove the layers formed on their surfaces due to the reaction with air. Now let's have a look on poorly reactive metals. They hardly react with oxygen, even if left in air, such as gold, silver, chrome, nickel, and platinum. What if you have a ring or a necklace made of gold? Will it react with air? Of course not. So we call these metals poorly reactive metals. As we said, why we are using these metals to make jewels? Because they hardly react, or they never react with oxygen. They retain their luster and shine. Now it's time for questions. What will happen if less reactive metals are left in moist air for days? Less reactive metals for days. So they will react with oxygen, of course, by time and form a layer on their surface, like iron rusting. State the scientific concept behind separating petrol components. Can you remember? Do you remember different boiling points? So, different boiling points of substances are used to separate the petrol components by heating the oil to separate each substance at its boiling point. Fill in the blanks. What and what are having low melting points, while what and what are having high melting points? Think about it. Wax and butter are having low melting points, while iron and aluminum, metal, are having high melting points. These are just examples. Metals are characterized by being, and they are softened by. So metals are good conductors for heat and electricity, and they are softened by, of course, heat. Electric cables are made of what? And they are covered by, of course, they are made of a metal, a good conductor metal, copper, for example, and they are covered by, of course, plastic, which is an insulator. Okay, students, let's watch this video together.
Do you know what water, air, and rocks all have in common? They are made of matter. Matter is something that takes up space. Now, you might be wondering why they all look so different if they are made of the same thing. But the truth is that everything around you is made of matter, just in different shapes and forms. Matter is made of tiny particles called atoms. Matter can be grouped into three main states: solid, liquid, or gas. To figure out which state of matter something is in, we need to examine its properties. A property is the way that something is that we can measure. The physical properties we will look at to determine state of matter are shape, mass, and volume. Mass is the amount of matter in an object. Volume is how much space that matter takes up. Solids are easy to recognize. Rocks, apples, pencils, and plants are all examples of solid objects. A solid object has a definite shape that doesn't change when you move it or put it in a container. They also have a consistent mass and volume. This is because the atoms in a solid object are packed closely together, so they do not move around. A solid will change shape only if forced, for instance, if it is broken or smashed. If you look around, you can find many examples of solid objects. Liquid is the next state of matter. Liquids have a definite volume and mass, but they do not have a definite shape. The atoms in liquid are still close together, but unlike the atoms in a solid, they can move around. This allows the matter in a liquid to flow. Because liquids don't have their own shape, they take their shape from their containers. The same amount of liquid may look very different in a glass and spilled on the floor. You can find examples of liquids around you too. Water, milk, and juice are just some of the liquids you might find. The third state of matter is gas. Gases have a definite mass, but they do not have a definite shape or volume. Like liquids, gases take the shape of their containers. Unlike liquids, gases will spread out to completely fill the container they are in. If a gas is not in a container, it will keep spreading out indefinitely. This is because the atoms in a gas are farther apart than atoms in a solid or a liquid, and so they can move freely. The air you breathe is an example of a gas. You might have noticed that you can't really see air. Often, gases are invisible, but they are still there. There are many different types of gases in the Earth's atmosphere, like oxygen, nitrogen, carbon dioxide, helium, and water vapor. Sometimes matter can change from one state to another. Water is a very good example of this. When water is frozen into ice, it is a solid. When it melts back into water, it is a liquid. When water evaporates into water vapor, it becomes a gas. Matter in all its states is everywhere. See if you can find solids, liquids, and gases around you.
Dear students, thank you for watching. See you later in other science episodes.